Hi, welcome back.
Hello.
This is Dad and Kids doing Dad and Kids coding, working on Advent of Code 2020, and we're on to day 11. So we're only a day behind at the moment. Once we finish this, and then we probably by midnight there will be another one, and we'll be 2 days behind again. Anyway, so the problem here is basically we have a seeding plan, and we're going to iterate. So we need to loop through and determine if the seat is empty. And so after one round, so there's two rules basically. If the seat's empty and there's no seats that occupied adjacent to it, meaning anywhere in the 8 squares around it, then it becomes occupied. And if it's occupied and 4 or more seats are also occupied, the seats becomes empty. So, and it does it instantaneously or simultaneously. So we look at each of these, and in the next generation, all these are going to become full because none of them have there are nobody occupied. So they'll all become full. And then, so that looks like this. And then we run the rule again, and it goes from this state to this state. And then we run the rule again and again and again. And eventually, we end up in this state where this iteration and the next iteration are exactly the same. So it stabilizes. So that's what we're looking for. We're going to keep generating new rule, or applying the rules each time until it stabilizes. And once it stabilizes, we will count the number of occupied seats. Okay, so let's do that. And okay, so I've already set up the tests. So let's run test day 11A. And Advent of Code doesn't have it, so we'll create it in Advent of Code 2020. Okay, so what do we have here? So we were passed a string, and we want to take the string. So string, and we want the lines from it, and then we want to. Okay, so let's do this in a couple stages. Current. Let's call this the current iteration. So I'm actually going to iterate through and do a couple of things with this. So let's just create current. Okay, so now in this example, it would be very convenient if we had floor all the way around it, because then when we're looking at a square, because we have to look at a square, we have to look at the seats all the way around it. But when we're at the edge like this, we would be accessing beyond the end of the array, and that wouldn't work very well. So what I'm going to do is I'm going to add a row of, or a set of empty spaces, floor all the way around it, and that way we don't have to worry about that. Okay, so so the first thing we want to do is we'll take those lines and we'll add collect, and we will add a so given a line, we will return the string period concatenated with the line concatenated with period. And so that should give us the a list of all of these with, so they all have a dot added at the beginning and the end. Okay, so now we need to put a row of dots at the beginning and a row of dots at the end to complete this. So then let's say current, and let's, what's the best way to do this? Let's call it empty, and I'm going to just say that this is current first, and I'm going to collect all the characters, and I'm going to ignore whatever character I have here and just include a period. And that's what I'm going to do there. Let's add empty here. And let's just save this and let it run a few iterations, or not a few iterations, step through what's happening here. And now we have that empty is a sequence of dots and current is this array. So now we want to just make current be current, oh, actually empty, an array with just empty in it, appended to current, appended to an array with just empty in it. So let's just see what that looks like. So now we can see, so now we have dots all the way around the outside. Now Smalltalk has a class called an array2d. And so what we want to do is we want to take this lines, or the sequence that we've got, join them together into one long string and create an array 2D of the appropriate size. So this is a two-dimensional array, and it's just a convenient way to do things. So let's keep adding here. So now let's say current is going to be a 2D array, and the number of rows will be current size, and the number of columns will be current first size. In other words, we'll take the first row and ask for that many elements. And then we will join up current. So we'll join current because right now it's an array of strings, and we'll join them together, which will produce one great big long string, and then that is how we initialize a 2D array. So let's save this again and step through the various stages just to see if we're getting the right thing. And now let's look and see what current is. Inspect this. So if we go to raw, we see it. So it's not showing us all of it. That's what the ... is in the middle. But we see there's a bunch of dots, and then the row and the row and the row. So it's produced this 2D array for us. So now the next thing we need is we need to have the next value. And let's set next to, well, it doesn't matter what we set it to as long as it's not the same as current. And then we want to loop and we want to say while, so we want that current is current equal to next. Actually, it should be previous, I guess, shouldn't it? Previous. So let's just call it previous. So while that's false, we want to create a new value. And then once we're done, we will return the count. So while we're going through this, we may as well count the number of seats that are occupied, because we're going to have to be looping through it anyway. So, okay. So what do we want to do here? So we want to iterate. So first of all, we want to set previous to current. So we'll say it's current value. Then we'll say current is going to be the previous one. Let's say deep copy. And what deep copy will do is we'll make a full copy of the value. Just an ordinary copy would make the two refer to common values, so we don't want to do that. Okay, so now we've got the current value and the previous value. So what we want to do is we want to go through the previous value and apply the rules to each one so that we can transfer and create the correct setting in the next iteration. So I just realized that I'm going to want the rows and columns. So let's say rows or n rows, and n columns. I'm just going to say calls for shorthand, and then I want to set these. So this is the number of rows, is equal to this, and we'll put n rows in here. And then this is going to be the number of columns. So we'll set n columns to that. And now here we want to loop through the rows and the columns. So, but we actually want to not include the first and the last one because they're empty. So we want to go from 2 to n rows minus 1, do, and let's just call this row. And then we want to go from 2 to n columns minus 1, do, and this is the column. Okay. So now what do we want to do? For each of these, we want to apply the rules. So we want to count the number of neighbors in the previous box. So actually we only want to do that if it's either empty or occupied, but let's just do it for everything because it's easier. Now I want to loop through the 8 possibilities, and the simplest way to do that is to I could write another double loop, but instead what I'm going to do is I'm going to say neighbors here, and I'm going to make the neighbors be the relative position of all the neighbors as points. So neighbors is going to be equal to the list. So we want the row above and the column above. We want the row above and the column itself. We want the row above and next column. I'm going to do this next line. So then we want the current row and the previous column. We don't want the current element, but then we want the current row at the next column. And finally, we want the next row at the previous column, the next row at this column, and the next row at the next column. Okay, so this is the...
That formatting is bugging me a little bit there on the right.
Want extra space here and
Yeah.
here. There we go.
There we go. Isn't that nice and symmetrical?
Okay, so I've done it this way so we can see that we're doing the 8 squares around this one. So above and to the left, above and to the right. This row just to the left, skipping the current one and the one just to the right, and the one next row, one to the left, next row in this column, and next row at the next column. Okay, so there's our 8 values. And now down here, we're just going to loop through those for neighbors do. And I'm going to just call this, and I'm just going to call it N. And so what I want is to count the occupied. Oh, so I only want to do that if, so I want to say is the previous at the current row plus the x value of n at the current column plus the n y and x. Okay, so this is the current row plus the offset from the neighbors, and the current column plus the offset from the neighbors. And so if all of this is equal to a pound sign, if true, then we want to add 1 to occupied. Plus 1. Okay. And we obviously need to set occupied. Let's just make occupied a local variable here. And set it to 0. Okay, so we set occupied to 0, then we loop through all the neighbors, seeing if any of them are occupied, and if so, we count this. So now occupied will have the number of neighbors. So if a seat is empty and there are no occupied seats adjacent to it, so if it's an L and there are no occupied seats adjacent to it, the seat becomes occupied. Okay, so if previous at row at column, if all this is equal to an L, yes, so it's empty. If it's an L and there are no occupied seats, so and actually, turn this down. And occupied is equal to 0, then, so if that's true, then next, current it's called, current at row at column, put a pound sign because it becomes occupied. So if it's empty and there are no occupied seats adjacent, the seat becomes occupied. Okay, that's if true. If false, then we've got more to do. So in other words, it's not an L and occupied equal to 0, so we're going to do a very similar test. So I'll just copy this over. So if it's occupied and 4 or more seats are also occupied, it becomes empty. And occupied greater than or equal to 4, then it's too crowded, so it becomes empty. So we'll set current at row at column, put L. So it becomes empty. And if that's false, then we are just going to transfer the value. Actually, we don't have to because we've already copied it, so we don't have to do anything in that case. Okay, so it's an L and it's occupied as 0. Then we make it occupied. If it's occupied and occupies more than 4, then we make it empty. Otherwise, we don't have anything to do here. Okay. So, and we were going to count the number of occupied while we're at it. So while we do that, so if current at row at column is equal to a pound sign, whether we just made it that way or whether it already was. If it is, then we're going to add 1 to count. Okay, and we need to reset count to 0 before we, at each time through this. So let's set count to 0. Okay, so this is a much longer method than we would typically write in Smalltalk, but
that was not a typical moment.
That was not a typical moment. So We do a bunch of setup, putting floor space all around the array. We set the previous to be nil so that this test will be false. And then while the two are not equal, we're going to save the previous one, make a copy of it to be the next, or the current one, or the next one. Set the count to 0, then iterate through all the rows and columns, except for the rows around the outside. And then for each of those, we're going to count the number of occupied sites by looping through the neighbors and accessing those. And then we'll check to see whether, once we know how many occupied there are, we'll check to see if if it was an L and it wasn't occupied, then and there's no neighbors, then we'll make it occupied. If it's occupied and there's too many neighbors, we make it empty, and then we'll count the actual occupied elements either way. Okay, so that's a lot of code, and it says that I'm missing a what? Close square bracket. Okay, so let's see where we. So that's the one for that. Right, so there we go. Save. There we go. Okay, so now let's proceed. Insta small integer did not understand at minus. Yes, okay. So small little detail, I have to put spaces here because the minus sign gets treated as part of the operator otherwise. So that's fine. Proceed. And the first one passed, and the second one, it claims that our correct answer is 2238. So let's paste that in there. Proceed. And what is happening here?
It's having a moment.
It's having a moment. Okay, fine. I'm not going to worry about that. So the test run's fine now, and now let's just go over and see whether we have the right answer. So scroll down and paste in our answer, and it's right.
There we go.
Okay, so let's continue to part 2. Hopefully this won't take as long. Haha. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats, they care about the first seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of these 8 directions. Okay.
No.
So the leftmost empty seat below would only see one empty seat, but cannot see any of the occupied ones. Okay. The empty seat below would see no occupied seats. Right. Also people... What? The empty seat below... Oh, yes, because they're all in the diagonals or straight up or straight over. Okay. People seem to be more tolerant. It now takes 5 or more visible occupied seats for an occupied seat to become empty, rather than 4 or more from the previous rules. The other rules still apply. Only empty seats that see no occupied seats become occupied. And okay. So, can we generalize the previous code to make it work for this? Well, perhaps we can. Let's go and look at our code first. So let's go to the advent of code and look at the day 11a code. So, probably what we should be doing is we should parameterize this by some blocks. So let's change this code and call it seat iteration. take the string, that's fine. We will take a find neighbors parameter, which will be a find block. Actually, it's just going to be a block. Let's just say that. Block. No, call it find. And let's say crowded and neighbors. Okay. So what are we going to do? So the whole thing about calculating neighbors is going to be something that will be done somewhere else. So we'll get rid of that. So what's going to happen is this is going to be the generalized thing that iterates through applying the rules, but it's going to call this block to find the neighbors, and it's going to care whether if there's this many neighbors, it's going to consider it too crowded. So n neighbors is going to replace the 4 here. Okay, and this whole how do we find the neighbors is going to move into another block. That's fine. So let's just call this find neighbors. How do I spell it differently?
Maybe without the U.
No, I spelled it here. Find neighbors.
That is very odd.
Oh, it's called find. That's right. Okay, let's just call it find neighbors because that's fine. Right. So find neighbors, and then we want to give it the values. So value, the first value is going to be previous because that's what we want it to search through. And we need to tell it row or value for the row and value for the column. So we're going to say that this is occupied. So occupied is going to be the result of that, and then we'll just get rid of this line because it no longer serves a purpose. Okay, so we come in here, we're passed in a find neighbors rule, and the number of neighbors that's too crowded. We're going to do the same thing to add the floor space all the way around, set the previous to nil, and then we're going to loop this until they become the same thing. Current is previous, deep copy, that's all fine, count is 0. Loop through the rows, or through the columns, calculate occupied as whatever the find neighbors block does, passing it the previous array and the row and column. And then if the previous at that row and column is empty and there's none occupied, then we'll add. Otherwise, if it's occupied and there's too many neighbors, then we empty it. And if it's now occupied, we count that, and then we return the count at the end. So that sounds right.
Sounds right. Famous last words.
So now let's go and look at day 11a and make it do the right thing here. So let's just copy this. So we're going to replace most of this code by a call to self So actually we're just going to return self, and now instead of find neighbors here, we're going to put in this code right here. So let's just get rid of this. So we're going to pass in a block, and the block is going to have several parameters, and the parameters are previous, previous, row, and column. And now we'll get rid of these up here because previous goes away. Row, no, not rows and columns. Actually, I don't think those will probably go away too. We still need occupied. And we'll set occupied to 0. And then we'll loop through the neighbors, counting them up. And then we'll, almost done, not quite. That's the end of that block. And then we're supposed to pass into this the number of neighbors. So day 11, what's it called? Crowded is 4 for day 11. And that's going to return the count, and we're all good. We're going to have a bunch of these that we don't need, so let's get rid of those. And there we go. So we're going to, this is the rule we're going to use for neighbors. This is still for day 11a, because what we're doing is refactoring now. We're taking the code out, moving it to a new method, and then making this so it calls that method properly. So we want to do a iteration on the string that we were given. We're going to use this find neighbors block, which it takes the previous array, a row and a column, and counts the occupied values. Oh, and when we're done counting, we want to return occupied as the result of the block. And we also want to pass along that 4 is when we consider ourselves crowded. Okay. So let's see whether that passes our day 11 test. And it does. That's a good thing. So now we can go and write day 11b, which is going to be a lot like day 11a, except that we're going to find, so this is day 11b now, and it's going to be crowded if there's 5. And now we need to find a better way to find out whether there's any neighbors. So, to see whether they can see any neighbors. So we're still actually going to want this because the x and y values are going to be useful. But we need to know how many rows and what's the maximum number of rows and columns. So we're going to have to add an additional parameter here. So let's just save this for the moment. Go change day 11a. So we're going to pass in 2 additional parameters, n rows and n columns. Okay. Yep. Okay. So I'll save that. And we need to go and change our this and pass in and rows. Oh. Okay, I'm going to do this a different way. It's actually a slightly nicer way in some ways. So I'm going to put these, instead of adding periods, I'm going to add something else. I'm going to add stars. Doesn't matter as long as they're not L's or pound signs, they'll work perfectly fine. But now I'm going to have a row of stars all the way around. So they're kind of like column walls, but it means that we don't have to worry about indexing, so everything's fine. So let's just make sure that day 11A still works. And it doesn't. Oh, because I changed the method and didn't fix it. Okay, so let's go back to our day 11A and take out those extra 2 parameters that I added. Wherever it is.
It doesn't seem we've moved.
Oh.
And call it 21 now.
Okay.
21 failed inputs. And a partridge in a pear tree.
So let's go back over and run day. Okay, so that works now. So that's good. So going back over here, so day 11B. So, so we only have these 3 parameters. And what we need to do is we need to go in each of those directions until we find a star. If we find a star, then we've gone as far as we need to in that direction. And otherwise, okay. So, neighbors do n. Okay, so n is a neighbor. And so let's say, let's create some temporary variables. Let's call it temporary row, and temporary column. And then we'll say that t row is equal to row, temporary column is equal to the column. And then we want to loop through repeatedly until, so this is going to be if this at t row at t column is that, then we'll do that. Okay, I'm going to say char. So I'm going to evaluate I'm going to save the I'm going to save this, and I'm going to say as long as this is not equal to star, so while true, then I'm going to say if char is equal to pound, then we'll add 1 to it, to occupied, and put another. Why is it complaining? Okay, so let's add char here as well. Okay, so let's just put these up here. Okay. So T rows row, T columns column. We'll get the character, and if it's as long as it's not equal to star, that means we haven't got to come to the wall yet. If the character is a pound, then we'll add 1 to the occupied count. And regardless, we will change T row. So T row plus NX. So this should technically have been NY, and T column, doesn't matter because we're doing it all the way around, is T column plus NX. Okay, so we're going to iterate through this while it's true, and then when we get done doing that, occupied will be the count that we want to return, and everything should be good, I think. Let's go and see. So let's run test date. Oh, did we update the right counts here? Probably not, because we didn't. So, so this one, your count should be 26 occupied seats. And we got 37. Oh no, we got 0. That doesn't sound right. 26 is what it said we were supposed to get right. Right. Okay. So it didn't quite work. Okay. Oops. No, it's not doing the right thing. Let's go and look at the code first and see if we can see what's wrong here. So occupied is 0. Loop through the neighbors. Get the character at that column, row and column, and check to see if it's a star. If it's not a star, then we'll keep looping, adding whatever the offset is to the row and column. And if the character is occupied, then we'll return occupied plus 1. That looks right to me. Let's go and look at the seed iteration method and see if we can see what's wrong here. So, we set current, empty, all that. That's fine, hasn't changed. While current's not equal to previous. We'll keep looping. Copy this over. 2 to n rows. Do this. 2 down columns to this. Find neighbors. So let's put a halt here. And see if we can figure out what's going on. Okay. So we ran to this point, and our array is as we expected. Our 2D array is, let's just look at current. Let's look at previous. Inspect this. Right, so stars, star at the beginning and the end. So that's all as desired. And occupied is occupied's an array. Ah, that's not right. Okay, so there's clearly the problem. Occupied came back from the function with the wrong value. Okay, so let's go out to day 11b and look at code for this. So I'm suspecting that we have the, so this is while true. And this is, there we go. So this is just in the wrong place. So this is how it should be. Okay, so let's proceed. And now occupied is 0. Well, okay. Oh, it should be 0 because this is the first iteration, and so there aren't any. So let's just try saving this and proceed and see what happens. Just took too much time. Hi. We interrupted the video that we were recording because the environment that we were using crashed, and we were using a beta version. Normally, if Pharo crashes, you can recover all the changes that you've made to your code very easily. But in the beta version, that's not working right now, so we lost all the work that we had done on day 11. So I recreated it, and in the process fixed the bugs that we were experiencing. So I'm very going to briefly describe the code that's there and add this to what we recorded earlier. So the tests are not changed, but here is what we did was we took day 11a and we factored out this seed iteration find neighbors crowded method. And then, so this is the day 11a, and it basically checks each of the surrounding squares to see whether they are occupied, and if so, adds it to the count. Day 11b does this very similar, except that it loops out, going out in each of those directions until we find something that's not a floor. As soon as we find something that's not a floor, we check to see if that is occupied, and if it is, then we count occupied. So that's the only difference between the two cases, and also that we use the 5 as the limit on how crowded we feel. So let's just look at the method itself. So this code is very familiar from the first round. I've just modified it slightly from what you saw a few minutes ago. So we set some things up. We add a wall, a star to each line, the end of both ends of each line and to add a first line and a last line that are walls. So now there is a guaranteed non-floor piece all the way around, which makes it a bit easier. Then we're basically looking for current and previous to be the same. So as long as they're not, we make previous be a copy of current, and then we go through and we go through all the rows and columns, and we call the block that we were passed to calculate whether the previous, what the count was for the previous value with row and column, and then we get the character at the previous row and column, and if it was an L and occupied with 0, then we store occupied a person at that point, and we add 1 to the count. If it was previously occupied and there was too many neighbors, then we replace it with an empty seat and we subtract 1 from the count. And we just keep going through this until we've done all the rows and columns. Then we go back and check to see if current is equal to previous. If it is, then we're done, and so we return the count. So that's all there is to it, and it now works properly, and we have completed day 2. So thank you for watching this with us, and we'll see you tomorrow. Thank you.